Hello everyone. In today's recitation, I'll be solving two problems from your assignment number 4. So the first problem is problem number 7.20. This is the question. You are asked to calculate displacement at point C and slope of the beam at point A, B and C by moment area method. So to start the moment area method, you need to first calculate draw the moment by AI diagram under the given loading condition. So this is the moment by AI diagram. You can draw this diagram by calculating the reactions at point A and B, and then draw the moment diagram, which I haven't shown. I have directly drawn the moment diagram here. So the coordinates is minus 8 by A and minus 8 by A at B and C. The next thing you need to draw is the deflection diagram. So my deflection diagram for this loading condition is denoted by the red here. So theta A is the slope at A, theta B is the slope at B, this theta C is the slope at C, and this small angle theta B by C is the angle between tangents at B and C. So from this diagram we easily see that TC by A equals to delta dash plus C, and from the similar triangle, delta dash by this length 6 plus 3 equals to 9 equals TB by A upon 6. So we get delta dash equals to 1.5 times TB by A. So deflection at C, delta C equals to TC by A, TC by A minus delta dash here. So delta dash will be minus 1.5 TB by A. So we can calculate deflection at C by calculating TC by A and TB by A. So to calculate TC by A is a moment of M by EI diagram between point A and C about point C. So TC by A would be moment of this diagram, this triangle at C, plus moment of this rectangle at C. Now we can calculate it by this. So I've got TC by A equals to minus 156 by EI. Similarly, calculate the moment TB by A equals to, I've got it, minus 48 by EI. TB by A is moment of M by EI diagram between point A and B about point B. So we need to calculate the moment of this triangular diagram at point B, about point B. So we'll get TB by A equals to minus 48 by EI. Solving, we'll get the deflection at C would be minus 84 by EI, which means the deflection is downward. Now we need to calculate slope at A, B and C. To calculate the slope at A, theta A is a small angle, so we can easily say that theta A equals to this length TB by A divided by this length LAB, which is equals to 6 meters. So theta A equals to TB by LAB, which will give you theta A equals to minus 8 by EI. To calculate the slope at B, theta B equals to, similarly, theta B equals to TA by B divided by this length, solving this triangle. So theta B equals to TA by B by this length LAB. Calculate TAB first. Is the moment of the triangular this diagram about point A now. So we'll get theta B equals to 16 by EI. To calculate the slope at C, we have equation theta C equals to theta B plus theta B by C. Here theta C equals to theta B, theta plus theta B by C. Theta B by C is the angle between the tangents at point A and B, at point B and C, angle between the tangents at point B and C. So we have already got theta B. To calculate theta B by C, so theta B by C is area of this diagram, area of M by EY diagram between point B and C. So by adding these two values, we get theta C equals to 40 by EI. That's all my answer. So I have also solved a problem number 8.60. Here we are asked to calculate slope at point A, and this is by virtual work method. The system of forces is shown here. We have a 12K force on BC. We have different I for different element, and the E is constant as 29 into 10 to the power 3 KSI. By solving a problem using virtual work method, first we need to draw M by EI diagram under the external loading. So if we draw the M by EI diagram of this system, we will get this kind of figure which coordinate with 30 by EI at its peak. So, and again we need to draw the M by EI diagram under virtual load. So what's the virtual load here? Since we are asked to calculate slope at A, we need to provide a moment, positive moment at point A, unit moment. So if we provide unit moment at A and remove all the external forces, I will get a M by EI diagram as this. So now slope at A would be integration of m dash dx by EI. So we need to integrate the whole part, but in this figure if you multiply m into m dash in the other two columns, because the moment due to external load is 0, we'll get 0 value. So we only need to calculate the multiply this part, the 30 by EI part, this part and this part. That means only multiply BC, only on the BC. If you, so we have given you a table for multiplication which will make your integration easy. So if you use the table for such kind of triangles, you will find the integration will be 1 by cx m dash l plus a. So after putting this value, I have got 75 by EI. So put the value of E and I and check your units, and you will get theta A equals to 4.14 into 10 to the power minus 4 radians. That's the answer. Thank you.